Now make that mother hammer sound like.
Similar triangle proofs part 1. I know you are super excited to come back to proofs. I'm promising you that this is going to be easier than the first time. And the first part, we are going to just review the ways that we can prove that triangles are similar. So I want to back up and review with you the 4 ways that we did before. Because remember, in last chapter, we had congruent triangles and we had a list of 4 that were legal. SSS, SAS, ASA, and AAS. So when we were trying to prove that 2 triangles were congruent, these were the legal ones. Okay, similar triangles, which remember this is the symbol for similar. Similar triangles, there's only a list of 3. We can still use SSS, and we can still use SAS. The third one is one brand new that we haven't used with congruent triangles, and that's AA. Okay, and I'm going to give you examples of how we can show all 3 of these are similar. So this is what we're going to focus on today, and we're going to look at some of these examples. We're not actually going to write proofs until part 2. Okay, next is, let's just go ahead and take a look at a few of these. So the first one that I mentioned was SSS. SSS, you have actually already done. Remember when we did scale factors and I had you line up the different scale factors to show if they were similar? It's exactly what you would do here. So just a quick review is you want to line up what goes together. So 26 would go with 39. So I'm going to line that up, 26 over 39. The 24 is going to go with the 36, so I'll line those up in a fraction or ratio. And then your last one is 10 and 15. So you put 10 over 15. So again, in order to prove, like if we wanted to write a proof, we'd have to show all 3 of these, and then you would divide them out. So when you divide these out, I'll just go ahead and do it for you. You would get 0.67, 0.67, and 0.67. So again, you have done this before, but now you're actually going to write yes, SSS. So these are similar because of the rule SSS. So I'm not going to go over another example because if they're not similar, you would just write not similar. These 3 have to match in order for it to be SSS. Okay, that's the only example. Let's jump into an example of SAS. So I'll give you a few seconds to write this down, and then I will show you how these are going to work.
Stacking my paper, my wallet look like a Bible. Look, I got girlies half naked. That look like the grotto. I always send her.
All right. Hopefully you have most of it copied down. Let's take a look then at what we have to do. Okay, so the difference here between SAS and the SSS is this A in the middle here. So we still have 2 sides that we still have to make ratios for. The only difference is that there should be an angle that's in the middle of these 2 sides. So if we look at example 1 here, you can see that we have 12, and this is tricky because 12 does not match up with 20. 20 would be kind of like the hypotenuse, so 20 would match up with the 15. So you want to be careful of a picture like this. It's kind of twisted, and it makes you a little confused on what matches up. But it's actually the opposites of what match up. So in this case, what you want to do is you're going to put the 12 over 16, because again, they match up, and you got to check that ratio. And that ratio is 0.75 if you divide it out. The other ratio then is the 15 over the 20, and if you divide that out, you get the same thing as 0.75. So first, you want to double check that the sides still match up. So they do, and we're good. So do you see where there's an angle in here? Hopefully you're thinking to yourself that these have vertical angles. So these would be similar because of side, angle, side. Because again, both the sides match up, and they do have an angle in the middle that is congruent. You don't know anything about this third side, so that's why we can't use side, side, side. Alright, number 2, you want to do the same thing. Now this is nice because they already have the right angle marked for us, so we need to check 12 and 8 match up with 5 and 3. So 12 over 8 we would check, and that would equal 1.5. And if I did 5 over 3 and I divide that out, I'm going to get 1.67. So since these two sides do not match, this is a no. They are not similar. So I just wanted to give you an example of why it doesn't work, because these have to match up the ratio still. Okay, the last one is AA. Now some of you may be thinking, why not AAA? Because that makes sense, right? There's 3 angles, AAA. Well, here's the issue. And it may not make sense, and AAA is not completely wrong. It's just a lot easier if you abbreviate it, right? Because if we only have to make 2 congruent parts, why do 3? That's just a force. It's adding an extra one on. Well, let's say that we have this, and we have 2 triangles, and it's clear that this one is bigger, the one on the right is bigger than the one on the left, and all we know is we have 90 and 90, and we got 25 and 25. So all we know right now is AA on both sides. Okay, now we know they're equal, because what is 25 plus 90? That gives me 115 minus 180 is going to give me 65. So the 65s here, just because we don't write them, doesn't mean that we don't know that they're there. So AA works because you know that the third angle has to be the same because of the equals 180 rule. Okay, now it's not that important that you know, but I wanted you to understand why you only need 2 A's and not all 3 of them. Alright, so let's take a look. So we have these triangles here. I'm just giving you ones that are tricky, that may seem a little disguised when you're looking at them, and you're saying to yourself, well, no, it's not true. These are not, I don't see 2 angles marked, so it's not true. Let's look at number 1. Okay, number 1, we have a triangle over here on the left. I'm going to highlight it in blue. And they gave us 40 and 80. And the triangle here on the right gave us 80 and 60. So all we know right now is that the 80s match up. So we only have 1 angle that is alike. We need to have 2 angles that are alike. So the problem here is that you have to think, I may need to do one more step. So if I were to try to figure out what this missing angle was in each of the triangles, I would see that 80 plus 40 on the left here is 120, which leaves me with this third angle being 60. And on the right here, 80 plus 60 gives me 120, which leaves me with 40 left in this other triangle. So this is actually similar by angle. They just didn't give you the third one to make you, to kind of see if you're lazy or not, because you have to check that third angle. Now the one on the right here, again, is disguised. So you have 2 different triangles. You have this small one, ABD, and then you have the big one of ACE. So, right here, they're disguising that they have parallel lines. So since they have parallel lines, you know that you have corresponding angles. See if you can visualize this right here. This and this corresponding, same position, which also makes these D and E corresponding to each other. So right now you have angle by this triangle. I'm going to show you later why A is actually a reflexive piece, but we'll get to that in a minute. So hopefully this helps you with disguised AA. Now what you'll do is practice how to label SSS, SAS, and AA before we write proofs in our next video.